Okay, so compression, which is the process of taking data and reducing the size of our data. So this can be 10 gigabytes and this can be 1 gigabyte. And that is what compression is. And we're going to cover two compression algorithms. The first one is run length encoding. And the second one is dictionary-based compression. So let's take a look at run length encoding and how it will compress our image here. Now this image represents the number 7 because we have ones represent white and zeros represent black. Now run length encoding works by finding consecutive runs and labeling them. So let's take a look at what we do. So in this first row, we have 6 zeros. So our corresponding compressed image using run length encoding is just 6 zeros. And we can use the form count type. And then the next row, we have what? We have 1 0, so 1 0, and 4 ones, and then another 0. And now we have our compressed image. So before we had 6 in each row. Now we have only 1 in this row, 3 pairs in this row, 3 in here, 3 in here, 3 in here, and 1 in this row. So we have 3, 6, 9, 12, 14 pairs in total, and we have pairs, so we have to times by 2 to get the count and type. So 14 times 2 is 28 data values. Whereas before we had a 6 by 6 image, which was 36 data values. So we have reduced the size of our image. Now, run length encoding is a special type of compression algorithm called lossless compression. And lossless compression preserves 100% of the original data, which means if you were sent our compressed image, you would be able to reconstruct the original image by simply applying the same algorithm in reverse. So instead of 6 zeros, you write for row 1, 6 zeros. And then for row 2, it's 1 0, 4 ones, and 1 0. And you can keep applying this down below to get your original image for the compressed image. So now let's take a look at dictionary-based compression, which instead of finding consecutive runs, finds patterns in our data and creates a dictionary. So can you see any recurring patterns in this image here? Well, we have a 0, 1, 0. We have another 0, 1, 0, and here and here. And we also have another repeating value, which is the 9, 9, 9, 9, and 9, 9. And so what we can do is create a dictionary to map these values. So we can say our dictionary here, and we can map our repeated patterns to smaller values. So instead of 0, 1, 0, a 3-digit representation, we could represent that as A. And for 9, 9, we can represent that as B. And so now we can use our dictionary to construct our compressed. So we have 1, 2, 3 rows. So row 1 is going to be not 0, 1, 0. It's going to be what 0, 1, 0 corresponds to in our dictionary. It's simply going to be A. And then 7, 8, because that's not a repeating pattern. And then A again. Row 2 will be A, 9, 9, which corresponds to B, and 4, 1. And then our final row, row 3, is going to be A, B, B. So before we had 8 columns and 3 rows. So 8 times 3 is 24. And now we have only 4 values in this row, 4 values in this row, 3 values in this row. So that's 4, 8, 11. So we have reduced the size of our image using our dictionary. And this is another lossless algorithm, which means if I were to send you your dictionary and the compressed data, you would be able to reconstruct the original image. So you would see this as your data here and say, what does A correspond to? Well, A corresponds to 0, 1, 0. So you would go 0, 1, 0, and then 7, 8, 0, 1, 0. And you would do the same for rows 2 and rows 3 using your image and your dictionary.